Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. We're going to the third type of finding the area under the curve. So this type, we have a combination of above and below the x-axis. So how do you find the area of such curves? So please remember, like I always say, make sure you go back and review previous video and check previous rules, especially understand the concept of how to find the area above the x-axis and how to find the area below the x-axis. Make sure you're conversant with it. Make sure you're also conversant with quadratic equation and polynomials as well. So it's going to come handy in this kind of questions. So knowing how to find the roots of a polynomial or finding the roots of a quadratic equation. All right. So before I proceed, like I always say, don't forget to subscribe, like, and share. I don't know if you're yet to click on notification bell. I don't know what you're waiting for. So you should click it so that when I post new videos, you'll be the first person to know. All right, so let's go. So like I always say, that when you integrate a curve, it gives you from that line of curve to the x-axis. Is that okay? So when you integrate, it gives you the area of the curve from that line to the x-axis, okay? So when you integrate a curve, okay, it gives you the area bounded by the curve within the upper and lower limits from the curve or line, so if it's a line equation, to the x-axis. So always remember that it always gives you from the curve or the line to the x-axis. So, but in this scenario now, what's gonna happen here is that we're gonna have we're gonna be shading areas above and below the x-axis. So it's not just gonna be above alone or below alone, but in this kind of questions, a combination of both. Okay. So how do we solve this? As usual, I'm gonna write down the steps for this as well. So I'm gonna say 5 steps or 5 rules, depending on how you want to do this. So the first thing you do is that you should always know that all the area that you have to derive will be positive, and if it's negative, you have to ignore the negative sign. Okay, so all area values derived will be positive. Okay, and if negative, you ignore the negative sign. Number 2, so because this is a combination of both above and below, so what I always advise you should split the graph, contain the total area, and separate the integrals with smaller areas. So that means try and break down the total area into smaller bits that have its own upper and lower limits. So it will be easier for you to understand. So that's the reason why I always advise that it's better for you to draw the graph, okay, or sketch the graph. It's not usually compulsory in most questions, but it's very important. All right. So what you do here, you split the graph. Containing the total area. So into separate integrals. Okay, so into separate integrals with smaller area. Okay, so the first thing you do, you split the graph containing the total area into separate integrals with smaller area. Then when you're done with that, you then rewrite each smaller area as a function with the appropriate upper and lower limit. So don't worry, I'm going to solve a question on this, all right? So, but I'm going to just write down the steps so that when we start solving, I can refer back to them so you know what exactly I'm doing. So the next thing, so you rewrite each smaller area as the function with the appropriate upper and lower limits. Okay. Then number 4, after you're done with that, so what you then do, you then solve each smaller area separately using any of the previously stated 5 rules for either the above the x-axis or below the x-axis. So the way we solved it in the previous video, you just do exactly the same thing to each of the smaller area. Okay, so you now solve each smaller area separately using the previously stated 5 rules or step, okay? Sometimes I call it rules, sometimes I call it steps, or either, okay? Above or below the x-axis. Then when you're done with that, number 5, the next thing you do then is that you then add all the resultant area from step 4 to give the total area of the shaded parts. Then add all the resultant area from step 4 to give the total area of the shaded region. Okay, and that is the 5 steps. So that's how you solve this. So the first thing, all areas must be positive. You split the graph, you rewrite each smaller with its appropriate upper and lower limits. You solve each of them separately. Then you then what? Add them. All right. So let's start. Let's solve an example for this. Okay. So let's pick an example so that it will make more sense to you. All right. So example. So let's assume we have this example here. We're told to find the area of the figure below bounded by the curve y is equal to x squared minus 4, okay? At x is equal to minus 1 and x is equal to what? 3. And the figure that was given was this. So this was the figure. Was something like this. Something like this. So we're told that this is the figure, and we're looking for between minus 1 and 3. So quickly, like I always say, step 1, all right? We need to first figure out what are we looking for here. But step 1, we need to just make it clear that the area must be positive, okay? So we must make this clear that the area must be positive. And when you solve and you get a negative, you ignore the negative sign. Now, the first thing we need to do is that we need to first know what are the values here and what are the values here. So what are the values here and what are the values here? Okay. So because this is a y is equal to x squared minus 4, so basically we need to find at x-intercept the roots, okay? So let's say, so then we now have y. So we have y is equal to x squared minus 4. And we know at x-intercept, all right, because this is where it crosses the x-axis, y is equal to what? 0. So that means we're going to have x squared minus 4 is equal to 0. So x squared will be equal to 4. So therefore, x is going to be equal to plus or minus 2. So that means in this, here is going to be 2, while this place is going to be minus what? 2. Now, but if you look at the question carefully, we're not interested between minus 2 and 2. We're interested between minus 1. So let's assume this part here is minus 1. And 3. Let's say this part here is 3. So that means we're interested here from this point all the way to this point here. So if I can shade it to make it easy to understand, so these are the points we're interested in. So that is the area that we're asked to look for, all right? Now, let's go to step 2. What does step 2 says? Step 2 said we need to split this graph containing the total area into smaller what? Into separate integral with smaller area, okay? So we have to split this graph now. So this is what we have. So we have to split it all the way down. So that means if you look at this graph, step 2, let me write step 2 here so that it will be easy to see. So step 2, so this is step 1. So step 2, okay? So step 2. Now we want to split the graph. So we're going to have, so the first graph we have a graph like this. And we also have another graph like this. Are you seeing it? So between minus 1 and 2, and we have another graph between 2 and what? 3. So this is what we are meant to look for. So this is the graph. So between minus 1 and 2, so this part here is what we have here, and this part is what we have here. Are you seeing it? So the next part, next step 3, we're now told that we have to rewrite each area as a function with appropriate upper and lower limits. So that means we'll have to rewrite this now. So step 3, we then have to rewrite this. So step 3, we're going to rewrite. So this one is going to be, we're integrating between 2 and -1. Are you seeing it? And the function we had was x squared minus 4, while the second one was, so this is for this one here, while for this one is going to be integral of what? Between 3 and 2, x squared minus what? 4. And that will be for this one. So you see, we've separated it into what? Smaller integral. All right, so what is step 4 then? Step 4 said that we have to solve each smaller area separately and using any of the 5 steps we've learned for above or below. All right, so let's go back. Let's solve each of the areas separately. So step 4, sorry. Let's solve each of them separately. So step 4. So the first one we have 2, 1, x squared minus 4. And the other one we have 3, 2, x squared minus 4. All right, so let's solve that. So then we now have x squared minus 4. If you integrate it, as usual, you add 1 to the power and divide it by the new power, minus integrate a constant is going to give us 4x, and that is going to give us 2 and 1. Now, when you integrate this, it's going to give us x 3/3 minus 4x, but this time the upper and lower limit is what? 3 and what? 2. Are you seeing it? So let's go to step 5. Oh, we're not done with step 4 yet. Step 4 said we have to solve, so we're not done. So let's go back. So we have to keep on solving then. So this is it. Then you have to substitute the upper limit minus when you substitute the lower limit. So we're going to do that. So we're going to substitute the upper limit. So it's going to become 2 cubed over 3. So if you've not reviewed my previous video, it's a very good time to go back and see how to solve definite integral and area under the curve when it's above the x-axis and below. Minus 4 into bracket 2. Okay, minus when you substitute, when you put the y, substitute with 1, it's going to give us 1 cubed divided by 3 minus 4, 1. And you get an answer. Okay, and when you press your calculator for this, the answer you will get is going to be -9. And like I said, you can't have negative. So therefore, it's going to be equal, the area for that curve will be equal to what? 9. All right, 9 units squared. Now we're going to go to the next one. So we're going to solve this one. So the same thing, we're going to substitute the upper limit, which is 3 cubed over 3. And there's an x here, I forgot to write, minus 4 into bracket what? 3. Minus, when we substitute the lower limits, substitute lower limit 2. So it's going to be 2 cubed over 3 minus 4, 2. You press the calculator, and this is going to give you 7/3. So therefore, the area is going to give us what? 7/3 units squared. Okay. Step 5. Okay. Step 5. What does step 5 say? Then you add all the what? Resultant areas from step 4 to give the total area of the shaded part. So we're going to go back and add all the area from step 4. The area we have is what? 9 plus 7 over 3. And this is going to give us 34 over 3 units squared. So that means the area of this curve here that we have is 34 over 3 units squared. All right, so I'm going to stop here. All right, I'm going to stop here. What I'm going to do is the next video, I'm going to solve maybe one more, two more examples. Like I said, if you have any question, don't hesitate to contact me. And I'm very, very much happy to respond as soon as I can. So it's very important that you subscribe and click notification bell. So when I post the next video, you'll be the first person to know. So I'll see you soon. I'll see you in the next video. Always remember that when you have a curve, okay, you have to solve the smaller area separately, and the area must always be what? Positive. All right. Thank you very much, and I'll see you soon.